In today's video, we're going to be looking at Chapter 20, Lecture 20, Learning Objectives 1 and 2, so our very first lecture within Chapter 20. So we're going to be looking at oxidation, reduction, balancing oxidation and reduction reactions using half method. So today's going to be mostly about balancing those redox processes. Okay, so when we are looking at a redox reaction, we have to use a half reaction method. So first, we need to figure out what's changing oxidation state so we can determine what half reactions we need to produce. So we're going to identify a redox reaction by looking at what's changing oxidation states. If species are changing oxidation states, we have a redox reaction. When we are balancing a redox reaction, we're going to use the half reaction method. And this method involves assigning oxidation states to atoms and breaking into two reactions, an oxidation reaction and a reduction reaction. Okay, so our next thing we need to do is looking at balancing those half reactions. And what we're going to do first is balance our non-oxygen, non-hydrogen atoms. After we've balanced out all of our other elements, we're going to balance out oxygen by adding H2O. And then lastly, we're going to balance hydrogen by adding H+. And at this point, all of your elements should be balanced. After you've done that, you're going to balance out your charge. So both sides of your redox reaction, or both sides of your oxidation reaction or reduction reaction, should have the same charge. So you're going to add electrons to the more positive side of the reaction. And you can use this, if you didn't do oxidation states, to determine which is your oxidation and which is your reduction, as you're going to add electrons to the product side of the oxidation, the reactant side of the reduction. Okay. Next, you're going to add your half reactions together. Ensuring that you have... Oh, sorry. I missed a step. Look at me. First, we need to multiply our half reactions in order to balance our number of electrons. Your oxidation and your reduction should have the same number of electrons. So you're going to do this by finding a common multiple. Okay. Next, you're going to do add. Half reactions together. And then, if you're in an acidic solution, you're done. If you're in a basic solution, you have to neutralize your H+. And we do this by adding hydroxide to both sides of the final added together reaction and canceling out any resulting water. So what's going to happen is your H plus OH minus will produce water. So after that you need to cancel out excess water. So water on both sides. And then you're done. So let us try out an example. So we've got the following redox reaction, and we want to balance it in acidic solution. So the first thing we need to do is assign oxidation states. It's not necessary, but it does help out. So oxidation states here on our reactant side versus our product side. So our reactant side, we have zirconium 4 plus, O2 minus, H1 plus, and then our product side we've got and sulfur 4 plus. On our product side, we have zirconium 0, oxygen 2 minus, sulfur 6 plus, and we have no hydrogen. So we can see zirconium is changing and our sulfur is changing. Our zirconium is becoming more negative, our sulfur is becoming more positive. So zirconium is being reduced, sulfur is being oxidized. Now we can break into our two half reactions. We have zirconium species going to zirconium. Let's go ahead, balance this one out. For every oxygen we have, we need to add that many waters. We have 3 oxygens on our left side, 0 oxygens on our right, so we're going to add 3 waters. And then we need to balance out our hydrogens. On our left we have 2 hydrogens, on our right we have 6. So we need to add 4 H plus to our left. And now we need to add in electrons to balance out the charge. There's a 4 plus charge on the left side, 0 charge on the right side, so we add 4 electrons. Let's do the same thing with the other half. So SO3 2 minus going to SO4 2 minus as well. So first thing, oxygen. So we need 1 water on the left side. Now we need to add 2 H plus on the right side. That will give us a 2 minus charge on the left side, 0 charge on the right side, so we need to add 2 electrons to the right side. And now we have electrons on both sides. We need to compare and multiply by a common multiple. So we have 4 electrons here, 2 electrons here, so we need to take this one and multiply by 2, giving us 2 waters plus 2 sulfites going to 2 sulfates, plus 4 hydrogens and 4 electrons. We can now combine the two equations, canceling out things that are the same on both sides. And we get the following balanced equation. And if you check, you actually have all the elements balanced, so that works out. And we are in acidic solution, so we are done. Let's try in basic solution, see how it's a little bit different. We can again assign our oxidation states. So on our reactant side and our product side, we have I minus on our reactant side, manganese 7 plus, and oxygen 2 minus. So going to oxygen 0, or sorry, iodine 0, manganese 4 plus, and oxygen does not change. So we see that iodine is going from I minus to I0, so it's becoming more positive, while the manganese is going from 7 plus to 4 plus, becoming more negative. So the iodine's being oxidized, the manganese is being reduced. So let's break into our half reactions. We have I minus going to I2. Balance out our elements, then balance out our charge, like so. And then MnO4 minus to MnO2, and 2 waters, 4 H plus, and then 3 electrons. Each of these will need to be multiplied. Our common multiple is 6, so we'll do 3 here, 2 here, and we get 6I minus goes to 3I2 plus 6 electrons, and we get 6 electrons plus 12H plus 2 MnO4 minus goes to 2 MnO2 plus 4 H2O. We can then combine our two equations, canceling things that are the same on both sides, and we get 12H plus 6I minus plus 2 MnO4 minus goes to 3I2 plus 2 MnO2 plus 4 waters. And again, if we were in a acidic solution, we would be good, but now we are in basic, so let's see how that's a little bit different. To go rewrite this. Oh, excuse me. This should be 8. Okay, let's rewrite this on our next page. So we have 8 H plus 6I minus plus 2 MnO4 minus goes to 2 MnO2 plus 4 H2O plus 3I2. We need to add the same number of hydroxides to both sides as we have H plus ions, so we'd add 8 OH minus to both sides. These will combine to produce 8 waters, which will then cancel out all of those waters, like so, and we end up with 4 H2O plus 6 M minus plus 2 MnO4 minus goes to 2 Mn2 plus 3 I2 plus 8 OH minus. Okay, that is everything for balancing redox reactions. And we will move on in our next video.